So after completing the press tool assembly, we have completed the first day of assembly lecture basics. So for moving forward, we are going to continue with the toolbars that are present in constraint toolbar. So till now we have seen coincide, contact, offset constraint, angle constraint and fixed component. Further we are going to see today's fix together and the remaining constraint. As well as we are going to see this move command. What are the remaining commands in move command? So to start with, I'm going to take new assembly here. Say mechanical design and assembly. So in assembly we are going to call some parts here. Say existing component, or we can say existing component with position anyone. So I'm going to take existing component. This command we have seen in the previous lecture. If anyone wants to see this command, they can refer the previous lecture. So I'm going to select on this title after clicking on existing component. Select the product title. Next we are going to browse the part. I'm going to take the base plate here. So this is our base plate. Say close. After putting up the base plate, we are going to call some more parts here. We'll take one guide pillar also. We'll manipulate it little bit. In X direction we are going to take it. And next part we are going to call here is guide bush. So for the next part we are going to say guide bush, existing component, product, guide bush, say open. This one also we are going to manipulate, but by using compass this time. So any option you can take for manipulation, either move command or you can go for compass also. This move command you can move the parts here. So to start with, we are going to see fix together command first. In fix together, I am going to select the constraint here. Next, you need to select the parts which you want to fix together and then say OK. So after fixing them together, we can see the history. It is showing fix together constraint is been applied. We'll say move command or manipulation command and we'll make this part move in Y direction. But you can see this part is moving individually even if we have applied the fix together constraint. This is because this option with respect to constraint is off. So if I put on this option and then if I try to move this guide pillar here in Y direction, this will move with the guide bush due to fixed constraint. Even if I apply the constraint here, suppose if I go for coincide constraint, select the axis of guide pillar and this hole, say update, both the parts will move together due to fixed together constraint. So this was fixed together constraint. We'll undo them. Say escape and then say Ctrl Z for undo. So we have removed the constraint fixed together here. It is used for making the axis to axis coincide or flat faces to flat faces coincide. So it is similar to coincide constraint only. Quick constraint, select axis and axis, say update. Similar way, suppose if I go for faces, coincide constraint, this face and this face. Again update and they are coincided together. One more time, I need this plate here, base plate. So for that we have this option. If I want to repeat this plate here in assembly, then we have this option, fast multi-instantiation. That will come under product structure tools, the last option. So fast multi-instantiation, I'm going to select the part which I want to repeat in assembly. You can see the copy of this part has been created, but it will not have any constraint here. If I want to manipulate or move it, I can just directly go for manipulation and we can drag here in X or Y direction as we require. Next, again go for quick constraint. This time we are going to take edges here. So edge to edge coincide will be taken place if I go for quick constraint and say update. So now these edges are being constrained. Similar way, faces, this face and this face coincided together and now they are constrained. So now as these edges are being coincided, not the complete faces, we can go for angle bed also here. Select both the faces in which you want to make an angle, then provide the angle value. Suppose if I say 45 degrees, say OK and update. So you can see here, as they were coincided with the quick constraint using edges, the angular constraint can be applied here. So this was quick constraint option. It can be used for axis, faces or edges. Next we are going to go for flexible or rigid sub-assembly. Suppose if I insert any sub-assembly here, suppose if I want to call any component, again I will go for this existing component option. Select the title as product and call the product here. So I have made this press tool assembly earlier for the lecture. So we are going to call this same assembly as a new sub assembly. Say open. We'll move it little bit. So I want to move it in Y direction. But you can see here when I am moving this assembly, it is moving combinedly as an assembly, not as an individual parts here. If I am dragging the top plate of this assembly, combined assembly is been moving either in X direction or in Y direction or in Z direction. Similar way, if I rotate it around the Z direction, it will combinedly rotate as an assembly only, not as an individual part. This is because this sub-assembly is a rigid assembly. So now if I want to move these parts individually, I need to make them flexible. So I'm going to select this flexible rigid sub-assembly, select this option and click on this product which we have called as a sub-assembly. Now you can see this color is coming pink. Earlier the parts were having color as blue color, but as we have applied the flexible assembly, that's why this color is showing pink. Means this sub-assembly has been flexible now. So if I go for trying manipulation command again, I will put off this option that is with respect to constraint, and then if I try to move this plate, it will individually move the plate only, not a complete sub-assembly. This is because we have made this sub-assembly a flexible one. So this was flexible and rigid sub-assembly. I'll undo it again and I'll say again this assembly as rigid. So just click and put off this option here. Say OK. If I again go for manipulate and try to move it, it will move as a sub-assembly only. So this is due to flexible and rigid sub-assemblies. Next constraint we are going to see here is change constraint. And if I select any constraint in the history, suppose this guide bush constraint which was made coincided with the face of the plate. Suppose if I select this constraint, then CATIA will show the possible constraint which can be changed here. So I am going to select this offset constraint. Earlier it is coincide constraint and we are going to change it into offset constraint. Say OK. You can see here instead of coincide now it is showing offset. Suppose if I want to apply the offset distance also, just double click it and you can go for the distance option. So I'm going to take this distance as 80 mm and say update. So now you can see this 80 mm constraint has been applied, and instead of having coincide constraint, now it is moving downsides due to offset constraint. This is done by using change constraint option. One more time, if I go for this change constraint option and instead of this angle mate, if I go for perpendicular mate, say apply and OK, these two plates will be perpendicular now. Say update. So this constraint is being changed from angle to perpendicular constraint. All this can be done by using change constraint option. We have seen the reuse pattern in press tool assembly in earlier lecture. So we are not going to repeat it again here. I'll delete this product. Earlier we have called. Next we are going to see the manipulation command again. I'll move this guide pillar to Z directions here. Whole complete assembly has been moving. So first I need to make this base plate fixed. For that I'm going to apply this constraint again, fixed component on this plate. So fixed component. Again go for manipulation command and I want to move this pillar here, but it is not moving. This is due to with respect to constraint option is on. So if I put off this option and try to move it in Z direction, it will again move it here. Say OK, and if I say update, it will again move to its original position as there was coincide constraint between the axes. You can see here. But suppose if I go for this option, that is in manipulate, if I put on this option again with respect to constraint, say OK, and now if I try to manipulate it from its side, it will not get manipulated in X or Y directions. It is because the part is following the constraint here, that was axis to axis coincide constraint. So if you want to move the part according to constraint, then put on this option. And if you don't want to move the part according to constraint, you just need to move them directly, then you can put off this option. Say OK and finish. Next option we are going to see here is snap tool. So for snap tool, select the snap tool, select this axis of guide bush and axis of this hole here. You can see here the last constraint in the constraint history table was fixed constraint only. But if I again go for snap command and try this face to snap with this face, it will get snapped. If I want to orient it to and fro, and this will get oriented in opposite directions. So this is the snap command, means positioning the part without having any constraint history or without making any constraints here. We'll repeat it here. We know that this guide pillar is having axis to axis coincide constraint here, but still if I try for snap, select this axis and this axis here, this part will move here, snapping the position. So it is only used in fixture design for positioning the parts together so as to see how the assembly will appear there. It will not going to have any constraint history or no constraint will be applied here. You can see still this fixed constraint is the last constraint in the constraint history. No other constraint has been applied here. Only the part positions are being changed using snap command. If I try this axis and this axis, it will move in that orientation also, but only having snaps here, not having any constraint. If I again say update, it will move to its original position with this whole reference. So this was snap command. Next command we are going to see here is smart move. So smart move is nothing but similar to snap command only. Suppose if I go for smart move, this axis to axis, it will grasp the position for the axis to axis has been coincided. But we can see here no made history has been created, means no constraints are been applied. Similar way, if I go for smart move again with this hole now, it will be moved according to the axis to axis orientation, snapping the position only. No constraints are been applied. But additional thing in smart move that separates it from the snap command, it is that automatic constraints creation can be created here. Means constraint can also be added here. In snap we were not able to add constraint, but in smart move we can add the constraints also by using this automatic constraint creation. So this is the main difference between smart move and snap. So we'll put on this option that is automatic constraint and then try this constraint here. So the guide bush axis and this hole, we are going to make them constraint. Here in constraint history, the only constraint is fixed constraint. But if I put on this option and then in mid history, in constraint history, the only constraint here is fixed constraint. But if I put on this option and go for this axis as well as the whole axis, the new constraint has been added, that is coincide constraint. So this is the main difference, that you can add the constraint also by using this smart move. So this smart move tool will work as snap also as well as to add constraints also. Both things we can do, and these things are very important while working in fixture assemblies. Sometimes we need to snap the parts for the position and sometimes we need to make constraint for these parts. Now here in quick constraint there are multiple constraints here. We can see we can try any of them here. If I need to go for angle constraint, so I'll put this angle constraint in order wise at the top position first by moving with this arrow. Now this angle constraint is coming at top. If I put on the planes option to show the planes, by going in this view tab, custom view parameters, select on this option customize view parameters and then put off this option no axis. So this time if I want by smart move the angle constraint is to be added, then we can go for that also. So I'll keep on this automatic constraint option, select the reference planes in which I want to put the angles. Suppose the plane of this guide pillar and the plane of this plate, and then say OK and finish. So here you can see this angle value is appearing as 180 degrees. I can double click it here and change the angle I want, or else if I go for this constraint and double click on this constraint also I can change the angle. So I'll say 45 degrees here and say update. So now you can see both the planes are at 45 degrees with each other. Angle constraint has been added here. This plane is being made angle with this plane by 45 degrees. So in this way smart move can be used. I'll delete this mates here, and suppose if I go for again smart move option and I want this offset constraint here, so I'll move this offset constraint at the top and then go for the offset constraint between the faces. So this time I'm going to select this face and the other face I'm going to take the reference of this plate side face. Say OK and finish. So offset constraint has been added. If I double click on this and go for the value, then I'll put the value here as 100 mm. Say OK and say update now. So this offset constraint has been added here, having the distance between this face and the guide bush face as 100 mm. So in this way we can use smart move option also to put the constraints. as well as for making snaps. Next command we are going to see here is exploded view. So for exploded view, I'm going to open one assembly here. I've already opened the assembly. Just go on this window option and change the window here. So I'm going to put on this assembly here, press tool assembly. And if I want to make this assembly exploded, so as to understand how the parts are been assembled with relation to each other, we can go for explode option. So here is the option in move toolbar itself. Beside this snap tool, there is explode command. Select the explode command. Here it will ask you the fix product. Means if I want to fix any part and then explode the assembly, I can do that. So for fixing this part, I'm going to select in this box and I'll fix this base plate here. Then at all levels, I want to explode it. I'll say apply and OK. Say yes. So now you can see all the parts are being exploded and can be seen at distance with each other. So as to understand how this assembly is been constrained. All the relations are also being shown here. Suppose if I want to move this top plate little bit upwards, so I can use this compass here. So in this way we can move the parts also here. Suppose if I want to move the guide bush this time, then select the guide bush, select the compass, drop it on the guide bush, and then you can drag this guide bush here. So you can change the parts position in exploded view using this compass. Again place this compass here. And lastly, if I want to exit the exploded view, I just need to say update here. The shortcut key for update, if you don't have any toolbar, then you can go for Ctrl plus U as the shortcut key for update. So now it is again updated and positioned at its places. So in this way you can use the exploded view. Lastly, we have this option that is stop manipulate on clash. Suppose if I call any one more part here, I'll go for this option that is existing component, select the product. I'll call the guide bush again, say open. I'll manipulate it. With respect to constraint, I'll put off this option here. I want to drag this part in Y direction. Now if I go and put on this option that is stop manipulate on clash. Suppose this option is off, then put on the option also. Say OK. And if I try to manipulate now, having both the options on, that is with respect to constraint as well as stop manipulate on clash. If I drag here in Y direction, this part will not intersect the base plate. You can see here, it will stuck while touching the base plate. It will not move forward. If I drag it in the left side, it is not moving. This is because stop manipulate and clash is on. Suppose if I put off this option and try to drag, then it will clash here with the plate and intersect the plate and pass on. So this option is very important to see whether the parts are being clashed together or not. This will automatically stop the part while clashing. Say OK and finish. Next option here is graph tree recording. It is used to manipulate the positions of the part in model tree. Suppose if I go for this option graph tree recording, click on the title, you will get this chart here to move the model tree parts and manipulate them by their order. So if I go for this guide bush and try to move it upwards, move the selected product upwards, this green arrow showing the direction at upper side, then this guide bush will be moved at the top. I want this base plate to be dragged to bottom. I want this top plate to be positioned at second number. I want this guide pillar number 4 to be positioned at third number. Means we are manipulating or moving the positions of the part in model tree. Say apply and OK. So you can see guide bush 3 is coming at top, top plate is coming at second number, guide pillar 4 is coming at number 3 position, and base plate is coming at bottom now. So in this way you can use this graph tree recording to manipulate the positions of the parts in model tree. So this was graph tree recording option. Next option is replace component. Now I'll change the window here, go to product 2. Before that, again I want some more copies of this part. For that I'm going to use this command fast multi-instantiation and click on this part. Again click on the part and you have this 3 guide pillars now. If I want to change these guide pillars to guide bush and replace them with guide bush, then you can go for this command that is replace component. Before applying replace component, I'll give one mate also here with one part or with one guide pillar. So for that I'm going to apply coincide constraint. Select the axis of this top guide pillar with this whole axis. Make them coincide with axis to axis. Now I will say replace part. Select the part you want to replace. Select the part you want instead of guide pillar. So I'm going to take guide bush here. Say open. It will ask you that these elements are going to be impacted by the replace component. Do you want to continue? If I say yes, it will continue. If I say no, it will not continue here. So I'm going to say yes and OK. So now you can see instead of guide pillars, guide bush are being shown here. But still the constraint which we have applied, coincide constraint with axis of guide pillar and this hole, it is still there. Means constraint will be continued but the part will be replaced using this command replace component. Next command we are going to see here, which is going to be used in drafting only, that is generate numbering. So if I need to make bill of material, I need to have the balloons also there. So in balloons we can show the numbering for these parts. So if you want the balloons with having numbering for the parts, then you need to compulsory go for this option in assembly itself, that is generate numbering. Select the product and it will ask you which mode you want, whether you want integers as numbers for the balloons or you want letters for the balloons A, B, C, D. I'm going to select integer only for the balloons. This is standard one. So I'll say OK. And now for ballooning in drafting for bill of material, numbers are being generated here. So these were the toolbars we were going to see today. We have seen this toolbar, move toolbar, all the options. We have seen constraint toolbar, all the options. We have seen product structure tools, all the options except these two. These are not needed, that is selective load and manage representations. We have omitted these topics here, and except that we have seen all the commands in product structure tools. So these were the three toolbars that were necessary for assembly, basics of assembly. But still if you want to learn the assembly in deep, you can join the course. The number for joining the classes to make the contact is given below in the link. You can connect us and join for the courses here. We also provide 100% placements based on mechanical courses such as SolidWorks, AutoCAD, CATIA, Solid Edge, Creo. Any course if you want to learn in deep, you can join here. You can join us by contacting us. And for now, we will continue with the further lectures for CATIA. So keep watching the CATIA playlist and subscribe the channel 4 Dimensions Infotech. Till then, thank you.